The building enclosure is designed to manage water vapor flow by considering the assembly of the structure, the materials used, and the climate. Generally, water vapor flow through the building enclosure can occur by airflow, since water vapor is transported by air, or by diffusion. The rate of vapor transported by airflow depends on the air pressure difference between indoors and outdoors, the air tightness of the enclosure, and the water vapor content of air. The rate of diffusion depends on indoor and outdoor relative humidity and temperature, and the permeability of the building materials. Several principles relating to diffusion of water vapor must be kept in mind. First, the building enclosure should be protected from large moisture sources. For example, vapor retarders with very low permeability rates are used on the ground in crawl spaces to minimize water vapor migration from the ground into the house. Second, moisture should not be trapped within the building enclosure between impermeable membranes. The enclosure needs to be able to dry to either inside or outside. For example, house wraps with moderate permeability rates are used in the exterior wall construction to allow water vapor diffusion. House wraps also function as water-resistive barriers and as air barriers, minimizing air-driven moisture. The primary sources of water vapor indoors are in the bathroom and kitchen. One can manage indoor sources of water vapor by installing and using bathroom and kitchen exhausts, and by controlling the indoor humidity through the proper design and use of the HVAC system. An HVAC system that brings unconditioned outdoor air into the house will increase or decrease the indoor humidity level depending on the water vapor content of the outdoor air. In high humidity areas like the bathroom, unfaced batt insulation is often used with mold-resistant wall board that includes a built-in vapor retarder. Dehumidifiers can also be used in basements to manage high humidity conditions. To prevent potential condensation on ductwork in an unconditioned space and improve energy performance, install the HVAC system, including ductwork, within the conditioned space of the house. If placing the HVAC system and the ductwork in an unconditioned space is unavoidable, then ensure that the ductwork is sealed and well insulated. There are many types of house wraps, and in some cases they have multiple functions. They can resist water, such as rain, and they can resist air when edges are overlapped and taped. Many house wrap products are designed to allow water vapor transmission to promote drying of the wall assembly to the exterior. On the other hand, some house wrap products are designed to be less permeable to resist inward solar vapor drive from moisture and absorptive claddings. Construction practices will vary by climate zone, and so will the material selection and assembly for water vapor management. Our video has demonstrated common moisture management practices within Climate Zone 4, around the Maryland and Northern Virginia area of the country. The water vapor management details for exterior walls shown here include an interior vapor retarder in the form of the craft facing on the batt insulation. During winter, the direction of vapor flow by diffusion is from interior to exterior. The vapor retarder minimizes this diffusive flow and thereby reduces the potential for moisture accumulation in the exterior sheathing. The permeable house wrap allows the sheathing to dry to the exterior. Other construction practices and assemblies will be necessary based on your climate zone.